This video is brought to you by IXL, used by millions of students worldwide to get ahead in math, English, and more.
Let's graph circles. This is the equation in standard form for a circle with center HK and radius R. It defines a circle made by the set of points xy that are all a radius r units away from a center HK. It's easy to graph a circle in standard form since we can read the center and the radius right from the equation. But what if we have an equation that's not in standard form? Well, in that case, we'll just rewrite it in standard form. Here are some techniques we'll need. A constant like 9 can be rewritten as 3 squared. This is often useful to find our radius r. An x squared term by itself is the same thing as x minus 0 squared. And the same idea works for y too. We'll need this when our circle center is at the origin. Perfect square trinomials can be rewritten in factored form. X squared plus 6 squared plus 9 is the same as x plus 3 squared. This helps us gather the terms of our equation into standard form. Let's look at some examples. Graph the circle x squared plus y squared minus 25 equals 0. This is not quite in standard form, so to graph the circle, let's first write it in standard form. Let's see, there's an x squared term, a y squared term, and a constant. Let's move the constant to the right-hand side by adding 25 to both sides. Now we can identify the center and the radius. We can rewrite x squared as x minus 0 squared, and same thing for y squared. We can rewrite it as y minus 0 squared. And 25? Well, that's 5 squared. So the center of our circle is 0, 0, which is the origin, and the radius is the square root of the right-hand side, or 5. So to graph this, let's first plot the center at 0, 0. Then plot 1 point on the circle. Since the radius is 5, the point 5 units to the right, which is 5, 0, lies on the circle. So this is our graph. How about this one? Graph the circle 2x squared plus 2y squared plus 20x plus 18 equals 0. Let's do the same thing. To graph the circle, first let's write it in standard form. It'll take a little bit more work to rewrite this one, so let's break it into steps. Step 1, move all the terms to the left side of the equation and divide out the x squared coefficient. It looks like everything is already on the left-hand side, but there is a coefficient on our x squared term. So let's divide each term in our equation by 2 to get x squared plus y squared plus 10x plus 9 equals 0. Step 2, complete the square in x. It looks like there is both an x squared term and an x term. That means we should complete the square and we'll be able to write this in factored form. Let's first gather all our x terms and put them in parentheses. Remember, to complete the square, we add and subtract a constant to make a perfect square trinomial. This means taking half of the x coefficient, squaring it, and then adding and subtracting it to the expression. So since the coefficient of x is 10, we'll add and subtract half of 10 squared. Now let's move our parentheses to group only our perfect square. 10 halves squared is 5 squared, or 25. So inside the parentheses, we have x squared plus 10x plus 25. Outside the parentheses, we simplify to get y squared minus 16. And finally, we can factor the perfect square. X plus 5 squared plus y squared minus 16 equals 0. Let's move that up and move on to step 3. Complete the square in y. This time the only term in y is y squared, so we do not actually have to complete the square. We can easily write y squared as y minus 0 squared. Step 4, move the constant to the right-hand side. We can add 16 to each side, giving us the equation of the circle in standard form. X plus 5 squared plus y minus 0 squared equals 16. When determining the center of the circle, remember standard form has a subtraction inside the squared terms. Let's rewrite the first term as x minus a negative 5 squared. Now we can identify the center and the radius to help us graph. The center is -5, 0. The square root of 16 is 4, so the radius is 4. Let's plot the center at -5, 0, then plot another point on the circle. Since the radius is 4, the point 4 units to the right, which is -1, 0, lies on the circle. And there's our graph. Sometimes it involves completing the square, but now you can graph circles from equations in general form.
Head over to IXL.com for more practice on this skill and thousands more videos in math and language arts.